Swayam Prabha. Digital India. Educated India.
We will start the next example. It states that following particulars refer to a two-stage velocity compounded impulse wheel means turbine. Steam velocity at nozzle exit is 600 meter per second, nozzle angle is 16, mean blade velocity is 120 meter per second. Exit angles are given, that is for first row of moving blades it is given as 18 degree. Fixed guide blades it is given as 22 for the exit, and second row of moving blades also has exit as 36 degree. Steam flow is given as 5 kg per second. Blade friction factor is 0.85. Here we have to remember that we are working with two stage velocity compounded, so the fixed blades are acting as nozzle. So, this 0.85 should also act for the fixed blades. What is happening in case of moving blades? We are having relative velocity which will be felt by the moving blades at the inlet. So, due to the friction factor we reduce the velocity which is relative at the outlet. Similarly, in case of fixed blade we have to reduce the absolute velocity at the outlet from the reference inlet. So, determine tangential thrust, axial thrust, power developed and diagram efficiency. First of all, we should draw the velocity triangle. And denote whatever it is given to us. So, we will refer this as alpha and this is beta 1, since this is V1, this is VR1, this is V2, this is VR2, so this is beta 2, this is delta, and then we have to draw second velocity triangle. So, VB will be same. So, this is VB and this is V3, this is VR3. So, this is alpha 1, now this is beta 3, this is beta 4, this is the angle at the outlet, we will say it as delta 1. This is VR4 and this is V4. Knowing this, we can work out with the example. Since VB is given as 120 meters per second, V1 is given as 600 meter per second, alpha 1 which is the nozzle, which is the alpha is given as 16 degree, since it is told that the nozzle angle is 16. So, alpha is given as 16 degree. Beta 2 which is the exit angle for the first row moving blades is given 18 degree. Then friction factor KB is 0.85, and then we are told that alpha 1 is 22 degree, since exit angle for the first guide blades. So, this is alpha 1, and then second moving blades. So, it is given as beta 4 as 36 degree. Knowing this, we should proceed with this example. We can first find out tan beta 1 is equal to V1 sin alpha divided by V1 cos alpha minus VB. So, we will have V1 is 600 into sin alpha sin of 16 divided by 600 into cos of 16 minus VB is 120, and this gives us 0.362. So we can get beta 1 is equal to 19.9 degree. So we found out beta 1. So we can find out from here VR1, since VR1 sine of beta 1 is equal to V1 sine of alpha. So VR1 is equal to V1, basically this is VA1 sine alpha divided by sine beta. So it is 600 into sine of 16 divided by sine of 19.9. So VR1 is equal to 485.78 meters per second. Now we are told that friction factor Kb is equal to 0.5. We know it is VR2 upon VR1. So VR2 is equal to 412.91 meters per second. So we can find out the outlet absolute velocity angle as VR2 sine of beta 2 divided by VR2 cos beta 2 minus VB is equal to tan of delta. So we are finding out this angle delta. Now we know VR2, we know beta 2, so we can make use of this. So VR2 is 412.9 into sine of beta 2 is given 18 divided by 412.9 into cos 18 minus 120. So we get from here tan delta is equal to 0.468. So delta is equal to 25.1 degree. So we got absolute velocity angle at the outlet. Now we are done with the inlet and outlet velocity triangle for stage 1. Now we will work for stage 2. We know that from stage 1, for stage 1 V1 was the velocity at the inlet, for stage 2 V3 is the velocity at the inlet, but V3 is inspired from V2. So V3 and V2 are the velocities at the for the fixed blade. So V2 is the velocity at the entry to the fixed blade and V3 is the velocity at the outlet of the fixed blade. So we have to use the friction factor between them. So friction reduces the velocity. So we have Kb is equal to 0.85 and then that is equal to V3 upon V2, and this gives us V3 is equal to 255.9 meters per second. Then we can find out tan of beta 3 is equal to V3 sine alpha 1 divided by V3 cos alpha 1 minus VB. Alpha 1 is given as 22, so 255.9 into sine of 22 divided by 250.9 5.9 into cos 22 minus 120. So this gives us tan of beta 3 is equal to 0.8175 and gives us beta 3 is equal to 39.26 degrees, and this is useful to find out VR3, which is relative velocity at the inlet for the second stage, and that is again we can have from VA3 is equal to V3 sin alpha 1 is equal to VR3 sin beta 3. So we can use this. So VR3 is equal to V3 sin alpha 1 divided by VR3 sin beta 3. So we have VR3 is equal to 151.46 meters per second. Now we can also find out VR4 from the fact that VR4 divided by VR3 is equal to KB. So we have VR4 is equal to KB into VR3. So VR4 is equal to 128.74 meters per second. So now we found out all the velocities required for the inlet and outlet velocity triangles for the second stage. Now we will go back and find out tangential and axial forces. So for that we will find out change in velocities. So delta VW1, here 1 means stage 1 is equal to, we know it as VR1 cos of beta 1 plus VR2 cos of beta 2. So we can write that down, and then we can get, we know VR1 cos beta 1, VR2 cos beta 2, and then we can get it as 849.44 meters per second. Similarly, axial thrust, for axial thrust change in axial velocity for stage 1 is equal to V1 sin alpha minus V2 sin delta. And so that we have found out deltas, we have found out alpha is known, V1 is known. We can find out this and we get it as 37.79 meters per second. We will go for second stage and find out delta VW2, that is VR3 cos beta 3 plus VR4 cos beta 4, and this gives us delta VW2 as 221.42 meters per second. VR2 is found, VR3 is found out, VR4 is found out, beta 3 is known, beta 4 is given. So from that we found out delta V2. So similarly delta VA2 is equal to V3 sin alpha 1 minus V4 sin delta 1, but this is also equal to V3 sin alpha 1 minus VR4 sin beta 4, since beta 4 is given to us. So from that delta VA2 is equal to 20.19 meters per second. So delta VW total is equal to delta VW1 plus delta VW2, and we get it as 1070.86 meters per second, and delta VA total is equal to delta VA1 plus delta VA2, and then that is 57.98 meters per second. So we can find out axial thrust is equal to m dot into delta VA total, and that is equal to 5 into 57.98, and then this is 0.0 0.29, this we will get this answer in Newton. We are expressing it into kilonewton as 0.29 kilonewton. Similarly, we can find out power developed, and this is m dot delta VW total into VB. So this is 5 into delta VW 1070.86 into VB is 120. So we have power developed. Here this amount is tangential thrust into 120 is power developed. So we will get power developed. This will come in watt. So we will get in kilowatt, that's 642.48 kilowatt. So we know diagram efficiency is equal to 2 delta VW into VB divided by V1 square. So we have 2 into 1070.86 into 120 divided by 600 square. So diagram efficiency is equal to 0.7139 or 71.39%. So this is an example for two-stage velocity compounding example, and here we understood one new point, that if friction factor is given, then we have to use it not only for the moving blades but also for the fixed blades, such that we should find out the absolute velocity which is approaching the moving blades of second stage, and rest of the things we should continue calculating as what we do for single stage impulse. And then we have to add the tangential thrusts, we have to add the axial thrust to get the total tangential thrust and total axial thrust, and then we can find out total power developed or the diagram efficiency. Thank you.